So good morning. We will be discussing Module 7, Kinetics and Chemical Equilibrium. Rate of reaction. The study of chemistry and its application mainly revolves on chemical reactions and in order for it to be used commercially. Knowledge on this area must be understood. In any given reaction or chemical reaction, reactants and products are defined in an equation balance and stoichiometrically calculated like in the production of ammonia for fertilizer use. A reaction is said to be useful if it is occurs at a reasonable rate. One does not simply mix nitrogen and hydrogen gases at 25 degrees Celsius and produce ammonia. Aside from stoichiometry and thermodynamics, chemical kinetics must be understood. So chemical kinetics is field of chemistry where factors that govern the rate of reaction are studied. The speed or rate of any given chemical reaction is the change in the amount or concentration of the reactant or product over a specific period of time. So the rate is equivalent to the concentration of A at a time 2 minus the concentration of A at time 1 over time 2 minus time 1, where A is the concentration of the product or the reactant in molecule liter, T is time and indicates change. The relationship between reactants concentration and time. From the above solution, notice that since the concentration of the NO2 decreases with time, it only follows that NO2 has a negative sign, as it is customary that the concentration of reactant decreases over time. Any rate of reaction involving reactant should have a negative sign. Rate law. Types of rate laws. Now, so we have two types. Number one is differential rate law. It is the rate law that expresses how the reaction rate depends on the concentration. While integrated rate law, it is the rate law that expresses how the concentration depends on time. Catalyst. A catalyst is a substance often used in order to speed up a reaction without itself being consumed. This can be done by the catalyst by providing a new pathway for the reaction that has a lower activation energy. With this, a large number of collisions are effective at a specific temperature and the rate of reaction is increased. Catalysts are either heterogeneous or homogeneous. So a heterogeneous catalyst occurs when gases or gaseous reactants are absorbed on the surface of a solid catalyst. A good example is the Haber process, wherein ammonia is synthesized from nitrogen and hydrogen using iron as the best choice of catalyst. Nowadays, manufacturing of ammonia involves the use of a mixture of iron, potassium, and calcium. A homogeneous catalyst occurs using a catalyst that has the same phase as the reacting molecules. Chemical equilibrium and equilibrium constant. Chemical equilibrium, as defined in thermodynamics, is simply the state at which the free energy of the reaction is at its lowest possible value. Also, it is the state where there is no apparent change in the concentration of the products and the reactants over time. Next is equilibrium expression. That is the expression obtained from multiple the product concentration and dividing it by the multiplied reactant concentration. Each concentration of the product and reactant is raised to a power represented by coefficient in the balanced chemical equation. Next is equilibrium constant. That is the value obtained when the concentrations of the chemical species in equilibrium are substituted in the equilibrium expression. So writing equilibrium constant expression, the law of mass action as proposed by Cato Maximilian Goldberg as a general way of describing a condition or reaction under equilibrium. Consider the reaction JA plus KB to LC plus ME, where A, B, C, and D are the chemical species, where A as J, KL, and M are their coefficient. Following the above reaction, the law of mass action is denoted by the following equilibrium expression. Significance of equilibrium constant values. Equilibrium constant are used to predict several significant aspects of chemical reaction, such as tendency of the chemical reaction to happen, which is specified by the magnitude of the equilibrium constant. Position of the equilibrium achieved based from the initial concentrations. If K value is equivalent to 1, it means the reaction system at the equilibrium will contain the products mostly, hence the reaction is said to be shifting towards right. On the other hand, if the K value is very small, the reaction system at the equilibrium will contain the reactant, mostly, hence the reaction is said to be shifting towards left. Factors that affect chemical equilibrium. From experiments, 3 factors largely affect equilibrium. So number 1, change in concentration. If a gaseous product or reactant is added to system in an equilibrium condition, the system will shift in such a way that will move away from added component. This is largely agrees with Le Chatelier's principle. Change in pressure. Adding inert gas increases total pressure, but it does not affect the concentration or the partial pressure of the reactants or products. In this condition, ideal gas behavior is assumed as the volume of the container retaining the gaseous system is reduced. The system also reduces its volume. Change in temperature. Compared with the previous 2 factors, temperature actually affects the system differently. Temperature actually changes the value of K. Using Le Chatelier's principle to visualize energy can be regarded as a reactant in an endothermic reaction or product in an exothermic reaction. This is, in turn, will also predict the shift of the reaction, like how a reactant or a product shift a chemical reaction. Le Chatelier principle. In order to qualitatively predict how a change in concentration affects as a system in equilibrium, we need to understand Le Chatelier's principle. It states that if stress or a change in condition is imposed on a system at equilibrium, the equilibrium positions shift to a direction that tends to lessen the stress. This principle is important to chemists and chemical engineers working in the production in order to predict which condition to choose to favor the production of the desired product. So thank you very much.